In this example, we're going to determine which of the models that we discussed would be the best model for each graph. So if you look at them, the second one over here on the right, it's pretty clear because you can see that U shape being formed by the dots. So it's clearly quadratic. The other one's actually not as simple. I mean, it looks pretty much like an exponential. I didn't draw that very well, but it looks like an exponential. But if I were to go and do this, you might say it looks now more like a linear. Or if I were to do this, you might think it looks more like a quadratic. Sometimes it's very hard to identify what type of model it is without knowing the context. Though since we're supposed to be able to identify which model is just by looking at it, I would probably say exponential is the best given this. However, it can be very hard sometimes to tell what the model actually is just by looking at the points without knowing the context. So there is a linear relationship between people's shoe sizes and their height. So we've collected some data on shoe sizes and height, and then we're going to do each of the following. So we're going to start by writing the equation to model the situation. To do that, we're going to pull up our calculator here, and we're going to go ahead and go down through and put in a table. So add a table and enter my data in. 7, 15, 10, and 10. Now for the y values, 66, 61, 67, 74, 69, and then 66. Now in Desmos, sometimes you might need to be, sometimes you might need to actually see the graph to determine what type of function it is. So there's this little magnifying glass at the bottom corner of the table. If you hit that, it should make the graph more visible. We're told it's a linear relationship, so we don't really need to do that. Bring it over a bit. There we go. So since it's a linear relationship, the linear model would be y1 with the squiggly, m x1 plus b. The y1 and x1 can change depending on what's up here at the top of the table. I had to use y1 and x1 because y1 and x1 are at the top of my table. Once you have that, the m and b to write the equation are right here. So the equation for the situation will be y equals m, which is 1.24, x plus b, which is 55.18. The second part of the question is asking us for the correlation coefficient. This is R in Desmos in most other calculators. So the correlation coefficient is 0.8808. If you think of it as a percentage, essentially it's like 88%, which is a pretty good representation of the data. So yes, it is fairly strong. The next one, predict a person's height if they have a shoe size of 9.5. So shoe size is our x values. Shoe size is in the x column. So there's one of two ways we could do it. We could plug in our x value into the equation. We plug in 9.5. Or, because we are using Desmos, we can take advantage of it. Since 9.5 is the x value, I'm just going to type in x equals 9.5. And then just like we've done in the past, we're going to find the intersection, which is right there. There we go. Since we stated the x value, the y value is what we're actually looking for. So the person's height will be about 66.96 inches, or about 67 inches. And the last part to this question is to predict a person's shoe size when they are 60 inches tall. So this time, 60 inches tall is in the y column, height is y column. Therefore, we're going to do the same thing. If we were to do this by hand, that means we would replace y with 60 and then solve it. Or we can take advantage of Desmos again and just type in y equals 60. Find where our line of best fit and our y equals 60 intersect. So according to our model, someone's shoe size, if they were 60 inches tall, would be about 3.887. And there we have it. In this example, we're going to find the quadratic equation for the relationship of horizontal distance and the height of a ball. We're going to round to 3 decimal places and then use the equation to find the height when the distance is 10 feet. So, to start with, we need to get the data in Desmos, our calculator. So to do that, you're just going to click on Add a Table, and then type the X and Y columns in. Just to save some time, I have actually already typed the columns in, if this will cooperate with me. There we go. So I've already typed the data in here. So to get a better picture of my graph, I'm going to hit the little magnifying glass. You can see that it does have that quadratic U shape, kind of upside down, but it does have a very nice quadratic U shape. Since we're doing a quadratic model, the model we type in is y1, squiggly, there it is, a x1 followed by the squared plus bx1 plus c. Once you get all that typed in, it should give you what a, b, and c are, so that we can write out our equation. So our equation this time, y equals -0.118, if I round to 3 decimal places, x squared. B is +2.112 if I round to 3 decimal places. So bx plus c, which is 4.215. So there is our equation. Let's answer the question now. So we are asked for what would the height be when the distance is 10 feet. Distance is in the x column. So if we were to do this by hand, we would plug in 10 in for our x and evaluate it. Or we can take advantage of Desmos. Since the x value is 10, I'm just going to type in x equals 10. They intersect right there. So if we have a horizontal distance of 10, we have a y value there of 13.547 feet. That would be our horizontal distance if our height is 10. Or sorry, reverse that. If our horizontal distance was 10, then our height was the 13.547 feet. Mixed up which one was X and Y. So the height of 13.547 feet.